Hello, welcome back. We're going to be continuing on with example 3. Damien and two of his friends are taking a road trip. They plan to share the responsibility of driving and will each drive an equal distance. Damien GPS shows the total distance is 172 miles. Determine the exact distance that each person should drive. Then determine a more appropriate driving distance for each person given the limitations on the situation. All right, well, first step is easy. We know there are 3 people. We have a total of 172 miles, so we'll divide that by 3. Let's see, 1 and 7 make 8, 8 and 2 make 10, so this won't be a whole number. We have 57.3. So we get 57 and 1/3, or we could write this as 57.3. And that little bar means the 3 is infinite. Because the distance given by the GPS is accurate to the nearest mile, the distance each driver should drive should be rounded to the nearest mile. Each driver will drive about 57 miles. Ichiro has saved $400 to spend on his 7 days vacation. He plans to budget his $400 by spending the same amount each day on the vacation. Determine the appropriate amount he should spend each day. Well, if you have $400 and you divide it by 7, you get 57.14. So that should be about $57.14 a day. All right, let's try over here. Think about it. The total cost of fuel for the trip was $20. If they split the cost equally, how much would each person pay? Well, if this was $20, we're going to take 20 and divide that by 3, and that gives us 6.66 infinity sixes. So if we were to round that, we'd say each person approximately owes $6.67. See, this part of the question, I don't understand why they have. Then determine the appropriate driving distance given the situation. There is no situations added. Example 4. Space Shuttle. In 2012, NASA Space Shuttle Endeavour traveled approximately 897 miles from the Kennedy Space Center to Houston, Texas by a shuttle carrier aircraft. Then it traveled about 1,381 miles to the Los Angeles International Airport. Finally, a truck pulled the Endeavour 12 miles through the street of Los Angeles to the California Space Center. If the shuttle carrier flew an average of 270 miles an hour, 287 miles per hour, all right. And the truck pulled the Endeavour at an average of 1.3 miles per hour. Determine the total amount of time it took the Endeavour to travel from the Kennedy Space Center to California. Because parts of the space shuttle journey from the Kennedy Space Center to Houston and then from Houston to Los Angeles are all the same speed, add those two distances. So we have 897 and 1,381. When we add those two together, we get 2278. All right, so we know we traveled 2,278 miles by air. From here, what we're going to do is we're taking the distance traveled and dividing it by the speed. By doing it this way, the miles will cancel and we get left with time. So we have 2,278 miles divided by 287. And we're going to add that to 12 miles divided by 1.3. Up, I got the total. I was supposed to do this in two parts. So we'll go 2278 divided by 287. And this gives us 7.9. We're just rounding one decimal because they gave us one. And then 12 divided by 1.3 gives us 9.2. So if we add those two together, 7.9 plus 9.2, we get 17.1. And we're using the approximation symbol, so this works. So the total travel time for the Endeavour from Kennedy Space Center to California Space Center was about 17 hours. Why is it unreasonable to say that it took 17.168 hours for the Endeavour to reach the Science Center? What's one? Sure. Here's the question. What is 0.168 hours? We don't really know. You'd have to do some calculation to get minutes. But 17.1 is close to 17, so about 17 hours. A school is hosting a marching band competition and plans to mail postcards, flyers, and large information packets to other schools. The school will mail 150 postcards with a cost of 34 cents in postage, and between 75 and 100 flyers, which cost 49 cents in postage. 43 information packets will be mailed. The cost of mailing the information packets vary, but the average is $1.59. Select the total mailing cost that represents the most reasonable level of accuracy. All right. So here we go. It says 150, so we have 150 postcards, and each one is going to be $0.34. We have to add. Now we have between 75 and 100, so let's average those two. We're not quite sure, but we're getting a cost approximation here. If we wanted to, we could just do it at 100 flyers, and that would give us a maximum cost, but we're just going to average this for some approximation. Over 2, and that costs 49 cents, 0.49. And then finally it says 43 information packets. Notice how 43 is written in words instead of that. They're trying to trip us up. And each one averages $1.59. So 150.34 plus, then we go 75 plus 100 divided by 2.49 plus 43, 1.59. So it says about $162.24. Hey, right there. That's a good one. Term inaccuracy. The U.S. Census Bureau website shows a counter that displays the population of the United States on a certain day as 329,158,023. How accurate is the reporting population? Explain. So it says we have about one birth every second, one death every 13 seconds, international migrant every 29 seconds, so a net gain of one person every 11 seconds. Because there is no way to count every person in the United States at any given amount of time, given an exact population doesn't make sense. The number of births, deaths, and immigration varies, so the population does not increase at a steady rate. The website uses averages to estimate the population at specific times. It would be more appropriate for the website to report the population as an approximation. We don't have an exact one all the way down to the person. So if we just reported, let's say, 329 million, That gives us a good idea. And that's with rounding, so it's an approximation. Finally, a science magazine reports that there are, on average, 37 trillion cells that make up the human body. Select the option that best describes the accuracy of this magazine. The magazine is accurate because scientists can count every cell. The magazine is probably accurate because the number is not very specific. The magazine is not accurate because there is no way to count all the cells. The magazine is not accurate because the number of cells is always changing. We'll say probably accurate. And we're saying this because 37 trillion. So just a reminder for here's 100, 1,000, million, billion, trillion. To say 37 trillion, that's a lot of wiggle room. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 decimal places. Like there's 12 digits here of accuracy that we've lost. So it's probably accurate because this isn't very specific. And that is it. Thank you so much.